All right, so we are going to just go through some guidelines for the programming project for end of term. The purpose of this is to just give you all a little something to be able to reference when you are doing your own project for the end of term. Is take it as a little recap of the searching and sorting techniques. Hopefully, we'll be able to get everything sorted in terms of, at least to be able to understand what is required and where we want to be, etc. So, and the term, sorry, before I go here, okay, so the program is, we're not going to do anything really too much associated with these first four, other than probably have a file that we will read. Okay, we're going to put some names in a file, we'll read the names in a file, and we want to at least apply the searching and sorting techniques to the names in the file. And we might or might not get to the point where we will take a look at the binary search or something so. Or maybe what I would do is I could use a linear search, right? I could pick one sorting technique, walk through that. I could use a linear search, and maybe we could take a look at the strategy for randomizing the items in the file. I don't want to do too much for you guys, right? Because then, then you're not learning. Agreed? Right. So we can come to, a nice midway point on that. So let's say, for instance, we have some names in a file. The names don't have to be in any particular order. All right. So we have, sorry, Ryan, Chelsea, Hannah. Did I spell that correct? All right. All right. So we have these names in the file, and we want to be able to apply some sort of algorithm, sorting algorithm to be able to order these names. Does anybody else have a name starting with any of these letters in class here? Huh? Oh, Aaron. And huh? All right. So I'll put in Chanel, Shaynelle, and Aaron, because we can't just we can't just apply based on the first letter. We have to take a look and put it in proper order. So if these are the names in the file, right? So we have a file with names.txt. And we want to read these names into some sort of structure. We were talking about what are we going to put these names into to manipulate them when we have to actually, utilize the program. Give me an idea, somebody. You all told me that we could have used one of two things. We could have used a string array or a struct array. And, each has its merits. Which way you all think, let me ask, who among us is going to prefer the string array and who will prefer the struct array, and why? If you were doing it, which one would you use? You say, all right, you might end up using a string array. Anybody would go the struct array route? No. Okay. It sounds easier to use a struct than a string. Okay. But my question is, are we thinking through a certain thing that we have to do? Huh? No. All right. Let me ask with context to something particular. You see this last part here? Allow for all the data in the file to be randomized. That might seem like an afterthought in terms of a task. But yeah, right. What you have to, you kind of have to start thinking through, right? Before we even, if say for instance, I don't even have these names arranged here in any particular order, but what if I asked you to write a program, solely to write a program to randomize these names from this file? I just want you to read the names from this file, randomize them, and write them back to the file. I already say too much. How are we going to do that? Hmm? That is a question. The questions usually start with like how. Right? Okay, I like that. Okay, so now we start thinking. We get in a justification. We say a struct could be used here because if we have a struct allows us to hold multiple variables of different data types inside of a single array, essentially, or a single variable, right? Which we could then make into an array. So Hazard here thinking, and we could put Ryan here, Sachin here, Chelsea here, Hannah, Eden, Chanel, and Aaron. And we'll put this in the name variable part. So let's say we have the name variable part of the struct. Then we have a value. And we could choose to, when we read this file, right, in terms of getting this randomized, assign a random value between 1 and the number of entries that are in this file, right? So let's say we get 9 here, 7 here, 2 here, 1 here, 8 here, 7 again here, and 1, 2, 3, 4, 5, 6, 7, right? And 8 again. Don't worry about the numbers. We work that out in the program when we do it. And to randomize this, we then decide to sort these numbers. This is to get the randomization. Because every time we create we do this read from this file. Every time we do the read from the file, what will we do? We assign a new random number to it when it gets read into the struct array. And when we want to randomize and write back, we then sort this in some manner, either ascending or descending, and then we could write it back to the file. Because if we sort it according to how it is here, we'll get Hannah, right, first, and then Chelsea, then Chanel, then what's after 2? 7, Sachin, then Aaron, then Ryan, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Yeah. And you see how we kind of did it's not the best sort, but each time that we run this is going to give us a different order, not so? Because each time that we run it, what is assigned to value is going to be different. Make sense? Think we could implement this little part of it now? So yes, to randomize, you sort based on the values that randomly assigned when the file is read. Hmm? Well, that's what we want to do eventually. That's what we want to do for this section, where we want to use both of the sorting techniques. All right, we want to use both of the sorting techniques. But what do we want to do for the sorting techniques? We want to count the swaps and the comparisons or whatever. Understood? But there's nothing. We're doing one thing at a time. We start off with allowing for data to be randomized in the file. So right now, our objective is to write an algorithm that will read some names from a file into a struct and then write back those names from the file back to that same file in a randomized order. And we just came up with our technique for doing that. How difficult is that to do? You can say it out loud. I see you shaking your head like that. You can say not difficult at all, right? Like a what? Nah. Okay, so, uh-huh. Yes. Right? So we're gonna assign the numbers using an SRAM. We don't have to use, we just need it bigger than whatever the value of the amount of numbers is there. So as we're reading from the file, we could count. We could count the amount of numbers in the file. And we don't even need to have it to the size. We could just say, okay, multiply that number by 4, just so that you have space enough to give so that too many recurring numbers wouldn't happen. And then pull a random number from that. We ready to hit the compiler? Yeah, thanks. All right. So I was expecting like, yeah. What? Mm-hmm. Why? I just felt it was a nice place to start. To me, it seemed like the easiest place to start. Why? What? You don't find so? Okay, I try not to read more than. Really, I mean, I think that wherever this stops is where Valia could move on. And I have time for it. We could totally change the subject. At the end of the day, I know that I will be able to do this, and I trust that you all will be able to do it too. All right? Huh? You don't trust? That's real trust. I have real trust in all you. Yes. All right. Is that trust misplaced? We real quiet. Nobody taking more on. Just all right. So let's put some names down in here, right? SACHIN. Sorry, I'm not typing properly. Jude. This we are taking rule 2. All right. Hazard. ELIJH. EARN. Eden. Brian. Chanel. Hannah. Chelsea. And Michaela. MEAY. Okay, so we have the names, right? So we have this is just names.txt. I thought so. Maybe not. Yeah. All facts. This change everything. All right. Okay, so we have the names, and then we want to have our actual C file, right? So we could call this rand underscore example underscore for what you call this, the end of two, right? Dot C. So we start off like a normal C file. We have our pound sign, include stdio.h. And we know that because we'll be dealing with strings in the future, we might as well include string.h, right? Because we have strings being read, and later on we might have to do some string comparisons or something like that. Correct? Might as well. So we have int mean, and where do we go from here? Int mean, what is the first thing that we have to do? We agreed that we're going to use a struct, right? So let's see if we could type define struct. Struct, what we naming this struct? Right, we can name it each now. And what is the data type, right? Uh, names. Okay. So we have int name, and this not int, sorry, char name. Okay, char name 40 and int value. And the value is just for the random value that we will assign when we read. So how do we go about reading a file again? Wow. Right. So we need a file pointer, and then we have to use fopen. Yes. Okay. So we have file fp, and then we can say fp is equal to fopen, and what do we want to open it as? Read. Right. So we open names.txt as type read. Everybody good so far? Cool. Where we go from here? We say if fp is equal to null, which means that if it is that the file doesn't exist, if the file does not exist, what do we want to do? We want to print out printf, right? Yes. File panic read error. Okay, something nice and cryptic so that it confuses the users and it will exit the system. So let's see if when we run this, if it reads our file that we just created just now. Yes? No. Right. So we don't get any cryptic error messages, and then it doesn't do anything else, which means that the file is read, right? The file is seen. So where do we go from here? We have to actually read the file. And we say while what? While n equal to file and the file for fp. What do we want to do? While n equal to file and the file fp, we want to, right, so we want to read a line and create the value. So to be able to read the line, we need to have a line char No, that's for writing to the file. Hmm? fscanf or preferably fget, yeah. So we would say char what? Char line, because we're reading a line of text from the file. We would say while in equal to file and the file fp, fgets, line has to be how long? 40. Fgets, line, comma, 40, comma, not stdin, fp. So we read a line while the file has data. Read a line of text from the file. Everybody good here, right? Okay. So just for now, let's just ensure that we can get everything out of the file. So let's just simply printf what we read from the file just to test it and make sure, okay? Line. And then we could printf end. This is test data. This is just to make sure everything working properly. Remember, since last year, we're doing step by step. Michaela is reading twice, and I feel that is because of that whole not the backslash, and it have this hanging indent here, which for some reason when you have files opening in the same processor that we just had, the compiler, it adds that automatically. So it's not the best thing to have the file open there. Let's see if that fixes. Yes, so you see, end comes right after Michaela's name. So we in again. We know that we could read the lines. Let's see if the lines inside of the names. But to do that, we'll need what? We'll need a variable that will store of data type name. So we have names, and what could we call this variable? Names, we could call it list. And we don't have to think too hard about our names, right? So we could store up to 500 names in this list. And let us see if we can, all right, let's see if we can now store these names in the list. So for us to store these names in the list, what do we have to do from line? To store the names, what do we have to do from line? First off, let me ask a question. All right, we want to be able to sanitize the input of all these names. I already remove it. So let me just put it back here. Printf %s line. Yeah? Oh, sorry. Yeah. Semicolon. All right. So what we know here is that after each one of these, there's a \n, not so? Which is why each one of them coming out on the last line, except for the actual last one, which does not have a \n. Do we want that \n stored inside of our struct? No. So we could strip this. Okay, we could strip this from inside here. When we are reading. So how do I do that? I could say if what? If the last character in the name that was read is a \n, then remove it. how do I know what the last character is? If line at position strlen for the same line -1 is equal to a \n, then what do we want to do? We want to make it into a \0. So if the new line character exists, remove it. So now if I run this again, all of these names come out on the same line. If I run it again, it does not, because I have a double equal sign here, not a single equal sign. So we just strip all of the \n from all of the names. Everybody understand what I did there? Because I don't want that \n stored inside of my struct array. It's going to cause problems when I'm trying to write back to the file. Right? I'll have to either accommodate for it or you know, and then you still have the last one to consider, the last line. But if I know that it's just the data inside of there, I am in control of my data. So I'm the one programming to deal with this data as I see fit. Any questions so far? No? Anybody head hurting or anything so? Not yet. Good. All right. I did see you shake your head. Yeah, but, you know. As bad as it seems, I just disregard that too. It's one of those questions I don't want the answer to. All right, it's Monday morning. I have a whole weekend to de-stress. You know? All right, so where are we going from here? We have it. We have to put it inside of the actual list. Okay, we also need a counter for the list. So, because this list is an array, so let's get a counter for the list, right? So, we could say int c, and this is our counter for the list. And because, you know, we would like it to start off at 0 at the beginning, c is equal to 0. So we get the name from the file, this line here. We clean the data from the file. This is debug data, really and truly. And then what do we do now? We want to actually put it into the struct. Yes? So to put it into the struct, we have to use, because it's a string, we have to use what to get it into the struct? Not tokenize. That's to break it up if it were long. Just to move it from one place to another is to string copy it. Yeah. Okay. So we will say strcpy string copy, and the destination is always first. So where do we want to put it? We want to put it in list at position, c dot name. And what do we want to put there? We want to put the data from line. So copy the name into the struct. What else do we need to do for C? For this name, there's some data attached with this name. We want to put a value, a random value next to it. Yes? Because the C is ordered. Because remember, each name will go 1, 2, 3, 4, 5 into that position. So we can't. It's harder to randomize an ordered list than it is to order a randomized list. Okay? So the C is also, the purpose of it is to act as the index, to keep track of all of the values. Right, and also to act as a counter, so that we will know how many values that that were read from the file at the end of it all. Okay, so the C has a really important job. The string copy, right, so now we want to get into the file randomization. To do that, we have to have this variable time underscore t, and we could call that t. We could set our srand to the top here, srand. How do we do it? Unsigned time ampersand t. Right, so set our random seed. So we set this random seed, and now we want to put a random number, any random number, right? Any random number inside of this array. Let's just mod it by 500. So it's a random number between 1 and 500, or 0 and 500. Okay? That should work well enough. So we should say list at position C dot value is equal to rand mod 500. All right, so between 0 and 499 should work. And then after this, all we want to do is C++. So at the end of the day, we can say, just to make sure that C worked properly, everything worked properly, we could say printf %d values were read from the file. Okay, so we have %d values were read from the file. I have to put what %d is, that is C. So 11 values were read from the file. 11. So only 11. Wow, it feels like more of you all were here. All right. So it's correct. 11 values were read from the file. Where do we want to go from here? Now, just for the sake of our own visual aid, we could print out the values and the name, right? So we could use a for loop. We could say for what? For int j is equal to 0, semicolon, j is less than c, semicolon, g plus plus. This int j wouldn't work, and I feel is a Java thing I try in here. All right? Mixing up my languages. Everything's a blur. Printf, what do we have to print out? We want to print out %s, comma, or let's just say a dash, %d. What is %s? It's names at position, not names, sorry, but list at position G dot name, comma, and list at position G dot value. And we have to put a \n after each one. And these are all of the values that, random values that get associated with the name. Yes. What I can put? I could have, I just wanted to print it out after everything was finished to make sure everything is fine. Right? But yes, I could have printed out as I was putting it in as well. It's essentially the same as each other. So now, what I would want to do is I would want to print these out according to sort these values here, 441, 167, 228, etc. And I would sort these values here and then print them out according to these values. Okay? And if you all realize that this last part that I'm doing here, I feel like I don't have to do anything else after this last part. Because this last part gives you all everything that you all need to do for everywhere else in the loop, except that I'm only using one sort. So it's either you want to see the selection sort or the bubble sort. I'm only doing one. If I had another sort at the top of my head, I'd probably use that one instead. Huh? Do the bubble. Do selection. Selection easier, yeah, to me, yeah. Well, both of them pretty easy. Nah. I swear you all. You're already getting so much. You're already getting, 50% of the work for all your assignment. Who else does that? Not answering. I give a little answer and then I'll get wise and decide to just stop and do something different, right? Why is it so tense in here? Everybody just so quiet. All right. So what is the next thing that we're going to do? Huh? Next thing is what? Right, we want to sort according to the numbers. But what will happen when we have to make a swap? When we have to make a swap, is it just the numbers that we swap in? No. It's the numbers and the name. It's all of the content inside of there that we have to swap. So we're being guided, right? We're being guided by the we're being guided essentially by the values to take us towards sorting in the manner that we want to sort. But really and truly, we have to move all of the data associated with that value, which is inclusive of the name. That makes sense? Yeah? Right? I don't know if teaching in person with everybody with mask on is worse than teaching online with everybody with cameras off. Because this teaching in person with everybody with mask on is like a game of poker we play. Just seeing everybody eyes and nobody giving any expressions as to what is going on. I can't read anybody's face. All right? Somehow I think hazard scheming right there, but I just can't prove it. All right? Okay. Somebody might be smiling at me or something, so it's like, your eyes too short. It's weird. Nobody's talking, which is not different from being online, so, All right. Give me a second, I'm just thinking about what we have to do. Okay, so we say that we have to we say that we have to sort this according to the values. So let's just see if we could sort the values, okay? And then maybe we could extend it, or maybe we'll extend it as we go along. So for us to do this sort, what do we need? I would suggest that we know that for a sort, we know that we'll have to swap values. Once you swap in values, you need a temp variable. So I would suggest that you just create a temp variable of the type of the data type names. Okay? It's just easy to copy the stuff across one to one rather than creating a separate temp for the string and a temp for the value. Agreed? Good. Anything else we need? Anything else we need? We might need some counters or something, so some very basic counters. We already have a J up here, so we could use over that. We could say for J is equal to what? 0, semicolon, J is less than C minus 1, and J plus plus. So we're going along with our bubble sort. Then we'll say for int k is equal to 0. K is less than C minus J minus 1, semicolon, K plus plus. We're going for a slightly more efficient bubble sort. Okay, so we're not going to sort over the areas that we know sorted. Each time you go around, you just swap with less values. You all understand? We spoke about that in class. You all understand where I'm going with this, right? Good. So we have this bubble sort. In the bubble sort, we know that we're looking at the value that we have now and the value that's right after it. So that those are the k values. We say if what? If what at k? If what at position k? If list at position k dot value is greater than list at position k plus 1 dot value, what does that mean? It means we need to swap. Correct? Yes? Right. So what are we swapping? We're swapping the name, we're swapping the value. Okay? So we'll say temp dot name. For temp dot name, we'll have to string copy. There is actually, I think you are supposed to be able to copy the contents of a struct just like it is. I think so, but I could never be sure, and I don't want to embarrass myself here, so I'll just do it name and value as it's just 2. But you should be able to just copy the entire contents of a struct right across. Okay, we could test it after, but let's get it to work, and then we test it after. That is one thing that, for some reason, you're looking it up for me? All right, thanks. Okay, so if it is that, we'll just do it after. Let's just go strcpy. String copy what? String copy temp, temp is the destination, dot name. And what do we want to put, what do we want to take? We want to take the value of list at position k dot name and put it inside. We want to say temp dot value is equal to list dot value. List at position k dot value. So we take what's in the current position and we put it in the temporary position. Then we'll take what is in the next position and put it in the current position. So we will then hit copy and paste. Take this here. This is going to be k. Let me just copy this. All right. So you want to take what is from k plus 1 and you want to put it inside of position k that you just copied out to temp. You're doing the same for value, right? You're doing the same for value. So you say list at position k dot value is equal to temp, sorry, not temp, but list start position key plus 1 dot value. And the last one is that you take the what is inside a temp and you put it inside of position key plus 1. Okay? So I'm going to copy this again. You're putting it inside of position key plus 1. So okay, so we just made this swap. And then after this, you want to, again, just print back out. You want to print back out. I'm not going to write to the file address yet. I'm just testing to make sure. Okay? So we're going to print out randomized values to write to the file. And we print out these here. Error J undefined. Oh, that's because I declared it int. Let's see int J during my time. Oh, okay, it works. All right. Okay, randomize 368. Hey, I did not get a. Did it change? It doesn't look like it changed. Didn't swap the names. No, but look, it swapped Judah and Sachin. Hazard still to Elijah Sheena came up. Okay, it did something, but then these should be in some sort of order. So maybe I did something wrong somewhere. Let me try it again and see. Hmm? For the swap. All right, I'll try that in a bit. A second here. Let me just see what I did wrong here. J is equal to 0, J is less than C minus 1, J plus plus. K is equal to 0, K is less than C minus J minus 1, K plus plus. String copy. If list that position K, that value is greater than list that position K plus 1, that value. Okay. So it's time to debug. Let's do a printout. Printf of %sign D. And I like to put my asterisk to show that I have my debugging information here. %sign D. All right. \n. And these values would be list that position. Oh, I made a mistake here. I didn't put K plus 1. So before I do all of that foolishness, I need to put K plus 1 here. Let's try that again. Okay, it's now in ascending order. So that was, I just didn't, I made a mistake. I didn't put K plus 1 when I copied and pasted down here. That's where the mistake was. Okay, so we don't have to go through that whole debugging or whatever. So it was more just like a little omission error that I did that throw off everything, right? So essentially, by assigning random values to here and then ordering them, I have really and truly randomized the list in terms of where everything is. Everybody understand what I did? Basically, if you look at what I did here, what I've done here really and truly encompasses everything that was above. It's just that instead now of doing a comparison on the value, you're doing a comparison on the name. And we know that we have a function that could do string comparisons to say which string comes before the other. That's strcmp. Okay, because it returns -1, 0, or 1, which will tell us whether the value is before or after. The first value is before or after the second value, or if they are the same. You all understand? So I don't think I have to go into that as that part. And I think that I've shown you all that we have the code, right? We could write the code that will swap these values inside of the array and from the file. And all we'll have to do to end this off is to write the values to the file. Okay, so we could have said fclose, fp inside of here. And if we want to write these randomized values back to the file, we could just simply fopen the file. What's the name of the file? Names.txt. We open the file for writing. And then we say we could use for int j is equal to 0, semicolon j is less than c, semicolon j plus plus. All we writing back to the file each time is printf. We could say printf, not printf, but fprintf. Okay, fp, comma, %s, comma, what's the name of it? List at position g dot name. If g is unequal to c minus 1, then you fprintf, \n. So that it doesn't print that last \n to the file. Okay, we spent a lot of time doing that last year. So let's see if this works. Okay, I'm gonna just put it in a file called names1.txt just to be able to compare it. Okay? And if it is that it works, then we'll just change it to name so that it overwrites this names1 file. Doesn't work off the bat because I forgot to put an FP here. Sloppy Mr. Valdez. All right, so File Explorer. Okay, so look at that. This was the original file. All right, we see it because it's the original order of how I took people in class. And this is the random file that got written to. And then we just want to be able to do that for, of course, in the program with searching and whatnot and tralala. Any questions? Any questions? You all feel like I deliver on what I promised to do today? You feel like I do more, like the whole assignment. I just corrected myself, right? haven't written it and just assign everybody the mark. Okay, Chelsea, what do you think about that idea? Yes. Oh, now I know Chelsea would have said yes. No, I can't do that. All right, but I will post up this video, and you all would use it as a guide. I'll post up the video. I'll post up the code, and you could use it as a guide to get into your own um, getting your own project done. All right, so I'm gonna stop the recording now.